In this session, we're going to see an example of phone interview. For this interview, I have generated and shared a Google Doc with the candidate, and I have recorded a Google Doc. Let me introduce the candidate. He got his bachelor's degree in chemical engineering and math, and he has already spent 20 years as a software engineer. In this interview, I have asked two questions. First one is to return true if the input numbers are rotationally symmetric. I'll give you the details what the rotationally symmetric numbers mean. The question number two is to count the number of islands. The input is the array to the function, and basically 0 means water and x means land. And then we're going to count the number of islands. In the actual interview, I give several examples. Once you see the examples, you can easily understand what these questions mean. Let's watch. Okay. Thank you so much for your time. So in this session, I'm going to ask you a few technical questions. So which language you want to use?
So I've been using Python, so let's go with that.
Okay, I love Python. Great. Let me give you my first question, which is I want you to write a function that returns true or false if a given input string is rotationally symmetric or not. Here's an example, like, input string is this 0891680, and that this string is rotationally symmetric along the center of the string.
Okay, so does that mean if you switch the numbers that it'll be the same number, or what do you mean exactly by rotationally symmetric?
Yeah, for example, like a 0, if you rotate in 100-degree 0, or the 0, and then it becomes 0. Like 9 or 6, like if you rotate the 9 by 180 degrees, it becomes 6.
Okay, got it.
So, and then like in this case, for the given string, along the center of the string, you rotate that string by 180 degree, you will get the same string.
I see, got it. Okay, that makes sense.
Yeah, but not 4 and 7. For example, like if you rotate 4, you cannot get 7, like a 2 and 3. Even though you rotate any degree, you cannot get 3 from 2.
Yep, okay,
All
I
right.
understand. Okay, so, yes, should I just dig in?
Yes, please.
Okay, so the first thing I think I would need is a mapping of the pairs of rotational symmetric numbers.
Uh-huh.
So, rotationally symmetric pairs. And I will just make that be a dictionary in Python. So 0
Okay.
maps to 0, 1 doesn't map to anything. 1 maps to itself, right?
Yes.
2, nothing. 3, 4, nothing. 5, 6, we said maps to 9. 7, nothing. 8 maps to itself.
Yes.
9 maps to 6. And that's all of our numbers. The next thing, so you said that it's a string that's going to be passed in?
Yes.
Okay. So let's do is rotationally symmetric. And it's accepting the value, we'll just call it.
Oh, yeah.
Okay. So basically iterate through this value digit by digit, pair the value with its cohort on the opposite end of the string.
Okay.
See if they're rotationally symmetric.
So
right?
you assume that input is a value or a string?
Yeah, so it's a string value.
Either way, it's fine.
Yeah. So let's, I see. So, I mean, we can force it to be a string, right?
Yes.
Okay, so if not is instance string, I think it's an order, we'll raise let's call it a data error.
Cool.
Okay, so we've got that taken care of. Now let's try to figure out, we're going to be operating from kind of both ends of the string. So I think we want to know the length of the string. So then so I guess we kind of need a pointer for each end. Is that true, or can we just calculate on the fly? I guess maybe we can just calculate on the fly. Let me start with this and see where we go. So for Let's see how we're going to do this. We want to go through, so for digit in value, will that work? We should be iterate through the string that way, right? Let's see, we can. If, but we need to know where we are. So let's say we start from the beginning. Oops. Position. Current position.
Yes.
Equals 0. So
Okay.
for digit in value, if the digit, so the what we want to first check is if there is a matching rotational symmetric pair. So I guess I would do this. Rotation. Pair equals digit, rotationally. Well, long.
That's fine. Yep.
So we're going to get this digit out of there. I guess it's an integer now. We're going to change this to strings. Maybe we'll change these to strings for so I don't have to do any casting.
So input is a string and output is also a string too.
Let's see. You know what? I'm going to keep them as integers because then I can just do a try block and handle it that way. Sorry.
It's fine.
Okay. So here. Okay. So yeah. Okay. So and then this could potentially throw. I think it's a key error we would get. And if there's a key error, then it means it's not rotationally symmetric, so we can just return false in that case. If the value that we're currently iterating through is not in this dictionary, that means it's not rotationally symmetric, and we can return false.
Okay.
Otherwise, we've got a rotationally symmetric pair. What we want to figure out is if this is the number that is on the opposite end of the string.
Yep.
Okay, so corresponding. So if let's see, if occasionally symmetric pair equals the value index position minus 1. This is a little weird. So what I want here is you can do like this would be, for instance, -1. So current position is 0, but we're going to. So I believe this is what we want. So so the end position equals the current position minus 1.
Yes.
Yes, minus 1
or length.
plus 1. Negative of that. Let's see. Hold on. What are we going to do here? Current position is going to be incrementing each time. Yeah, so we want negative value of the current position plus 1. Yeah, current position plus 1, I think is what we want. I could be wrong. Actually, the first thing I'll do probably before starting this is write a test to assert the various conditions, but I'll skip the test for now and we'll just go with this.
So what are you going to indicate here? Like for the current position is 0. Which value do you want for end position?
Yeah, we want -1.
Okay.
So let's do -1 times the current position plus 1. Okay, let's assume that that's what we're doing, and then we'll just call this end position. It's a little weird, but yeah, let's go with that. I can probably make this a little clearer in the past. So if the rotational symmetric pair is equal to the value at the end position, then we can continue. Actually, if not rotational, if this is not equal to the value, then we will return false because we know it's no good. Otherwise, we will add 1 to the current position. Okay, let's see. Will this work? Let me test it with my number here.
Okay, so which test case you can think of?
So I'll just use the example that you gave and go through this. All right?
Yep.
Okay, so we're passing in 0 first time through. It's strings. Sorry, we're passing in 0, the string 0891680. It is a string, so if that goes past. We're at current position 0. For digit in value, I believe this is going to iterate through the string. So the first one is 0. The rotational symmetric pair is 0. The end position is -1 times 0 plus 1, which is -1. So the value at -1 is 0. Rotation plus 0 is equal to 0. We skip this, then we add 1. So the next time we are getting, sorry, this is not good. Digit, yeah, that's right. The next time we get the second digit, which is 8, we get the 8, and it's -1 plus 1, 2, -2. That should return the right thing, I believe. And it's going to compare 8 and 8, and we just keep going, so that should work. What if we did like, okay, some test cases. Yeah, so this is where it'd be helpful to have a test that would cover this. Test case. What if we just do like, take off one of the numbers? Is it going to get confused? That seems like it should fail because the first one, 0, won't map to 8, so we'll... Fine, what about case, what if we just do empty string? Going to happen here. There are no digits, so this is return nothing, right? Actually, yeah, we're never returning true. That doesn't seem good. Okay, so the first case, so we want to return true when we've made it through the whole thing, and we would never return false. So actually, this one didn't return true until this would happen. So that's good that we tested it. But for this test case, empty string, so we want to make sure that the current position basically advances, right?
Yes.
So return current position is greater than 0, and actually that's all we get. So make sure that we went through at least once.
Okay.
So that'll make this one. Actually, is this a rotational symmetric number string?
That's a good question. I guess not.
Seems like not, right?
Right.
And actually, this seems like a little bit of a, I don't know, not the most straightforward way to measure this. So what we really want to test is if we can cast it to an integer, right?
Yes. And you can just check there if the length, if the string is empty, you can just return false.
Yeah, that's true too. So let's do the same thing here. So we can change this one back to true. So we made it through if length val equals 0.
Yep.
Let's be
Not be empty. Yes.
okay. So that one passes. If you do test case, not numbers, AA, that should be false because it's not. It's going to raise here, I guess. So
It's going to raise an error, right?
it'll raise an error. Yeah, I'm just trying to figure out where it's going to raise an error to make sure it does. When we're looking up the rotational symmetric pair for the digit, it'll return a key error, so it'll return false.
No, what I mean is that isn't it code at the second line of the function? The value must be a string.
So this is a string, right? A.
All right. Okay. Sorry.
Yeah. So I mean, we could
This is
cast
string.
it to an integer and then test that.
All right. Okay.
That's one way to do it.
I
That's
understand.
probably a better way to do it, right? Because then we don't have to worry about this part of it.
Sorry.
But since we're handling this anyway, I think
It'll
it
be
doesn't hurt to do it there. But yeah, I could see
Yep.
it'd be a little clearer to check whether it's an integer value first.
Okay.
Either way. So the one thing I did want to test is, or I was thinking about as you gave me this example was, if there was an equal number or an even number of integers, does it do the right thing?
That's very good.
And let's see, as we're going through, so 0 would be -1, 1 goes to -2. Yeah, it seems like it should go through. Oh, you know what I'm doing? What I'm not doing is when we get to the midpoint, right? Yeah, that's problematic.
Yes.
So we want to make sure that we're, let's see. want to make sure that we're less than halfway through, less than or equal to halfway through the string.
Yeah.
So if let's see, if the current position is less than or equal to, wow, this is a little ugly, but let's try this. Length of the value divided by 2. That's going to be, make sure it's an integer. Okay, so this is going to be if this happens, we want to theoretically return true because no, if we want to do this after checking, right? So if we're here, we can return true because we made it to the midpoint.
Yes, that's great. Yeah.
So if we're greater than equal to, right? If we're, no, hold on, let's see here. Yeah, sorry. So we, no, this is not right. Okay, so when we get to the halfway point, we are, yeah, if it's strictly greater than, is that right? Yeah. Because when we get to the halfway point, we're equal to this value, and we need to do one more pass. Then we iterate once more, and we are greater than the halfway point, so we can return true. Seems right. This is a little ugly. I'm not very happy with my function right now, but
yeah, it is correct.
It's correct. Yeah.
Yeah.
So.
Yeah. You wanna remove this line, and other than that, everything's correct.
Yeah, sure. Okay. Okay. So 2 things bother me. One thing is, this is a little ugly. It feels like not the right way to go about this, and this is bothering me for some reason. I think there's probably a better way to track our midpoint access, but.
But I think the length function actually returns an integer, and if you divide that integer by 2, it will be an integer.
So we don't need this.
I think. Yeah.
Okay.
Yeah, that's it. I think you did a very good job. Yeah.
Yes, I'm not very happy with it, but okay, thank you.
I'm happy. Yeah. All right. Thank you so much. I love the answer. Great. Can I move on to the next question? You have any question?
Do it.
All right. Okay. Next question is something a little bit more challenging. Not really super challenging. So what I want you to do is to where is my cursor? Yeah. Here's an example. Let's say that your input is an array of characters or strings, and then I want you to count the number of islands. Basically, this is a map, and then 0 means the water, water, and X is the island.
Yeah.
And then I want you to count the number of islands. And let me give you another example, like this is actually 2 islands because they're connected. Right?
There are 2 islands because the first 2 are connected?
Yes, these and these 2. Oh, God. Yeah, let me change the color.
Nice. Okay.
And
it's not connected because it doesn't have a same. I see. Okay, so this is 1 island with. Got it. Okay, that makes sense.
yes, because island can be connected if they are like top, down, left, right, not the diagonal direction.
Okay.
Yep.
Okay, so you want to count the number of islands in the input matrix?
Yes.
Okay, and the data is passed in a matrix format?
Yes, matrix format, and it has characters.
It has characters 0 or X, that's it,
Yes.
right?
Yep.
Okay, so what we want is a count islands function, right? For input matrix. Call it now. Okay, so let's think through this. It seems like what you want is you want to know, you're going to have to compare the previous entry's positioning to see whether your current row is has a island in the same position, in which case it's a contiguous island and you're not incrementing. So
Okay, let me stop here. We're going to continue watching the phone interview in the next session.